before we learn to use links, we'll just do a little bit more looking at select and how it works, inserting and selecting, because it's kind of fun. It feels like using actual code instead of like a weird database language. So first of all, we have these city types with name, properties called name, and also modern name, and yeah, Unicode is these strings are Unicode, so you can give yourself a city called I don't know, Happy Cowboy or whatever this emoji is. You know, anything you want, anything that is Unicode. So we can go ahead and do that. You can also, if you want to make a string, get the bytes of a string, all you have to do is put a B in front of it. So Jonathan Harker, and then that is going to be the bytes of Jonathan Harker, and it shows up as a B there, but it's actually the raw bytes. And of course, for bytes, you can't have special characters, so you can't do this, for example. So bytes are only ASCII chars, chars or cars, however you want to pronounce it. So there we go. So we have yeah, 3 cities in our database right now, and this we mentioned in the last video. So every time we made an insert, it returns the city that gets or the object that's been inserted. So I guess in some databases you have this return keyword, but you don't need that in EdgeDB. It always returns you by default the object that was worked on, which means the object you inserted or updated or even deleted. So if you're deleting something, it'll actually give you the ID of the objects that you deleted. And as mentioned before, this is a UUID, universally unique identifier, and that's used everywhere pretty much. So let's do our first select. So if we do select city, that just means select every object that is of type city. And you can see, so it shows up there, and we can see our 3 cities. Of course, we don't know, we can't tell as humans what their names are because we didn't ask to see their names. All it's going to show is the ID. So all we know here is that there are 3 city types in the database. So what we can do instead is we give it a shape. So we say we want a city, and the shape, this is why this is EdgeDB is called a graph relational database. So it's a relational database like Postgres, which is, Postgres is on the back end, but it's also graph. So you get this this shape, this graphical sort of output. So here we're going to say I want the shape of the city to be the modern name property. So it'll say, okay, here you go. Here are the 3 cities, and instead of showing the ID, it shows you the modern name. And you can see there's Budapest, there's Bistrica, and then the modern name for this one, this is what was it, Munich, I think it was, and it doesn't show up because it's not a required property, and instead we have an empty set. So just remember, this is an empty set. It's not null. It's quite different. So you can work with it like any other piece of data. So there we go. Yeah, so yeah, we know that it's Munich because we just remember that it's Munich, but to actually prove that it's Munich, we would do this. We say, okay, now show me please the name as along with the modern name. So you can see there's Munich in the modern name, and so on. And so you can do that. So those are and you can see it's showing that it's returning us some objects. But you can also, instead of an object, you can follow the path. So let's say we wanted to just do modern name. We want to see all of the modern names in the database that are connected to these cities that are like owned by the cities. And so we can use this dot operator to get the path. So here it's just going to return a set of strings. So it's saying, okay, here are all the strings that that are found under the modern name property under the type city. So now we can see instead of getting this default city, we're just getting a bunch of strings, a set of strings. So in EdgeDB, this is called a path expression or a path. And so you can keep on, if a city had a link to something else, and that, say you have a link, city link to a city, and that of course has a modern name, then you go city dot, whatever the link name is, dot modern name. And so you can keep on going after these paths as far as you can, as far as the paths actually exist. So just keep on using that dot operator there. And then another thing you can do, so this is where we start to get into computables, which is things, properties evaluated on the fly. So inside city, so it's got name, but let's say we would like to give it another name. And we can say, okay, I would like you to give me this property called name in Dracula, and this is pretty simple here. I want it to be equal to name. So for the moment, we're not doing anything fancy with it, but we are saying I would like to have a different name. So maybe in your application you have a some sort of type, and it needs it to have this property name in Dracula. So instead of changing your type or your schema, you can just say, okay, inside this query, I want you to return this as these names here, and then it's going to show up as name in Dracula, name today. So it's kind of a nice convenience here. So yeah, it's not touching the schema at all. It's just inside the query here. And let's see, .name is short for city.name, which is correct. That's just a little note here. So let's say we want to call something n. You can say .name, which is just short for city.name. So just so you know that. And then we can also make these quick computables by, we don't have to just reference, like say n equals .name. We can also say, anything else. In here we call it O, and by the way, but just put anything else. So we can just decide on the fly that this query inside city is also going to have this extra bit of info, and we're going to call it anything else, and it's going to be a city called, or a string called anything else. But later on, this will get into like computables. So just to give you a little taste of that, you can say like, I don't know, what's a good idea? Maybe like sometimes like the count of a city or something. Let's try c equals count number. This is going to be 1, of course, but number of names. You can do that. So if this was a multi property, then it might be more than 1. So we can do like these quick calculations on the fly, which is pretty nice. And let's see what else. Another kind of nice thing. Let's say you want to, select as a keyword, and you're not allowed to use it. So you can just enclose it. You can use these backticks. I like select. For some reason you really want to use the word select, then you can give it these backticks, and then it'll show up as name and select. So that's nice if you have something that you want it to have, you want a query to have, words like type or is or anything like that. And so finally, the last part of this video is just a little bit about type safety. So as mentioned way back, it's EdgeDB is strongly typed, which is nice. So it does a lot of the, strong typing does a lot of the thinking for you. There's a little bit of work up front, but it makes sure that you don't mix types. And so I'll just copy and paste this query in here. So here's a query that's not going to work because, let's put that over 2 lines. So you can see We're doing a select city. We decided that we want to get these computed properties, give them our own names, and then here we're going to take a string and then add an integer to it, and delete this thing here. And this is not going to work because you cannot add strings to int64, and that is the default type. If you have an integer, it's going to by default it's going to be an integer 64 bits. There's also 32 and 16, so you can choose to change it with a cast, which we will look at fairly soon. But by default, you can see, even if you're not, and this is the important part here, even if you're not telling EdgeDB what the type is, it'll strongly it'll use a strong type. It'll decide this is a string, this is a 64-bit integer, and it's not going to mix them up with each other. So that is pretty nice. And then we can also prove that these types are strongly typed. So you can say Jonathan is stir, and it's going to say true. We can say select 8 is int64. That is also true. And then select 8 is int32, and it's going to say false. So you can see it's not going to just let you mix things up. It will decide that this is going to be an int64. Actually, I might as well just show some casting here. So if you decide, just to finish up the video here a little bit nicely, so here we have a 20, and it's an int64, but we can do this cast here and say, instead of an int64, we want an int32. So give us that, and then it'll change it to that type. So it's pretty easy to change from one type to another, unless, of course, 3012, something like that. If the input is invalid, it's not going to just change it. So you can't trick it that way. But if you have like a 20 and you say we want it to be a different size integer, then that's a really easy thing to do. So that is how casts work. We'll do some more casting later on. And so there we go. And we're finally going to do some links in the next video.